Okay, so guys, we want to look at trigonometry today. And when we say trigonometry, what exactly are we trying to talk about? Or what exactly examiner wants you to know about trigonometry that makes it to be part of the topic that you have to study in mathematics? If you are in a higher institution and you are studying mathematics, we call trigonometry course of courses. It's not just a topic on its own or a course. It is a course for other courses for you to know how important it is. Like I can even say, aside from algebra, is another most voluminous aspect and most useful aspect of mathematics. Aside from algebra, very, very important. If you now understand this very well, it's like you know 1/3 of mathematics. You understand trigonometry very well, because it's going to assist you to do well in calculus. It's going to assist you to do well in algebra. It's going to assist you to do well in geometry. And I dare to say it's going to assist you in statistics and probability in some cases. And I'll show you one now. Let me show you something about what is it called? Algebra. How trigonometry will help you in algebra. Look at this question. 3 raised to power of x plus 4 raised to power of x equal 5 raised to power of x. This question is so simple that with just by looking at it, you can tell me that x is equal to 2. But it's so difficult that we find it difficult if you don't know mathematics to that point whereby you can relate algebra to trigonometry or go deeply into algebra, such as knowing mathematical induction. So, but with a better understanding of trigonometry, this question can be something so simple. And I'm going to show you now. We have said that x is equals to 2. If we can look at it, the first thing I'm going to do here is to divide through by 5 raised to power of x. If I divide through by 5 raised to power of x, you get to see that this and this would cancel. And then you'll be having 3 all over 5 all to the power of x plus 4 all over 5 all to the power of x equal 1. Now, if you have this, you get to see something I want to do now. I want to call your attention to something. You know, there is this mathematical equation. You know, if I have a sine of an angle, my result is going to be opposite over hypotenuse. And if I have cos of an angle, my result is going to be adjacent over hypotenuse. If I have the tangent of an angle, my result is going to be opposite over adjacent. And in any of the trigonometry function, you get to see that the only one that have the same denominator out of the 3, because after these 3, the ones you are going to be having now is the reciprocal of these 3 that make it 6. Like reciprocal of sine is going to give you cosec. Reciprocal of cos will give you sec. Reciprocal of tan is going to give you what? Cot. So if you look at it, you see that it's only sine and cos that has the same denominator, of which you can observe here. That's what? The denominator of this one and this one is the same, but they have different numerator. Likewise, sine and cos has the same denominator but different numerator. So the question you should now ask yourself is that, okay, what can make me add sine and cos together to get 1? What will be the power of sine and what will be the power of cos? And you can see that Having what? Sine square theta and cos square theta, that will give you 1. Are you following now? Sine square theta plus cos square theta will give you 1. And if you don't want to go like that, if you assume that this is a triangle, because we have 3 different digits there, if you assume that, okay, it is a triangle, and here is the opposite. So let's say the opposite is 3, adjacent is 4, and hypotenuse is 5. We therefore have that sine of theta is going to be 3 over 5, and then cos of theta is going to be 4 over 5. Are you seeing this now? So if you look at this and this now, you can use this to substitute for, what's it called? 3 over 5 and then 4 over 5. Are you guys following the explanation? I can't hear you. Are you following?
Yes, sir.
Yes, sir.
So if you look at this now, I can now say 3 over 5 is the same as saying sine theta. Sorry. The same as saying sine theta all to the power of x plus cos theta all to the power of x equal 1. If this is what I have, if this one equals to 1, and I have that sine square theta plus cos square theta is also 1, then I can compare coefficients to have sine of theta all to the power of x plus cos of theta all to the power of x equal sine square theta plus cos square theta. So do you understand the comparison now? So now I'll now say, this is addition that is in between them, and this one is sine, this one is also sine, this one is cos, this one is also cos. I can say compare coefficients. Sine theta to the power of x is equal to sine theta to the power of 2. Also, cos theta to the power of x is equal to cos theta to the power of 2. And if you compare coefficients, you see that base and base are equal. Base and base are equal. If base and base are equal, power and power would also be equal. And that makes you have that x equal to 2 in this particular one here. And here also, you see that x equals to 2. And you're able to solve it. Do you guys understand this now? So, if you don't understand what we refer to as trigonometry, you might probably not able to solve this question because you find it difficult. You just know that your answer is 2. How do I arrive at 2? You don't know. You don't know how you're going to arrive at 2. So we need to pay. That's the reason why we need to pay maximum attention to this topic, because I'm not going to stop at where it's supposed to stop in mathematics, but I'm going to stop at where it's supposed to stop in further mathematics. Because normally, there's nothing like further mathematics. Mathematics is mathematics. But we just feel like, okay, covering all of this under mathematics might be too much to cover other topics also. Okay, if you're interested in knowing this, then go and continue it in further mathematics. So that's where we're going to stop here in the class. So we're going to stop under where further mathematics stop their trigonometry. So without any further ado, can we get started? Can I clean this? I'm asking, can I clean it?
Yes, sir.
All right. Okay. So, trigonometry. When they say trigonometry, what exactly they want you to know in it? What is that thing that exactly? This is what they want you to know. When you're talking about trigonometry, what you just want to understand and know is 3 things. Your focus and attention should be to understand 3 things. And what are those 3 things? 1, You want to understand the relationship between one angle and the other. You want to understand the relationship between angles. And that's why in some textbooks, they define trigonometry as the study of angles in different perspectives. They say trigonometry is the study of angles in different perspectives. They are correct. That's one. Two, you also want to know the relationship between triangle and another triangle. You want to know the relationship between triangle and another triangle. That's the second thing. The third thing is that you want to know the relationship between angle and sides of a triangle. You want to know the relationship between angle and side of a triangle. You see, those three things are basically what we want to study or what we are supposed to know under trigonometry. So let's get started now. I'm going to start from the very basic one, and that's the trigonometry ratio. The trigonometry ratio. Now, what is trigonometry ratio? Write down. Suppose we are given a triangle, a right angle triangle. Take down that. I might not be able to write fast. Suppose we are given a right angle triangle, ABC. We're given a right angle triangle, ABC, where A and B, and C are the angles in the triangle. Are the angles in the triangle. They are the angle in the triangle. And the sides, the side facing A is labeled as small letter A. The side facing B is labeled as small letter B. And the side facing C is labeled as small letter C. Are we there?
Yes, sir.
As shown in the diagram below. As shown in the diagram below. As shown in the diagram below. So, if I call this A, and I call this B, and I call this what? C. So, anywhere A is facing is going to be small letter A. Anywhere C is facing is going to be small letter C. And anywhere B is facing is going to be small letter B. Then, we have this to be angle 90 degree. Are you following?
Yes, sir.
Now, for better definition of the sides, we say let C be the angle okay, let me put it like this. Let C be theta. So we are considering what? C to be theta. Now, at this point, pay attention now. I'm not going to clean the triangle because we need to make reference to it at every point in time now. So if I have this, we already say let C equal to what? Theta. That is, angle C is theta. Now, why do I say let angle C be theta? I want to define the three sides of a triangle. You see, the three sides of a triangle is called adjacent. They are called adjacent. I want you to pay attention now. The three sides of a triangle, they are called what? Adjacent sides of a triangle. That's the name given to the three sides. That's their general name. Adjacent sides of a triangle. But all these adjacent sides of a triangle, they are named according to some relationship that happens within the triangle. All these adjacent sides of a triangle, they are what? They are named based on the situation that occur or arise in that given triangle. What are we talking about? Because here is an angle theta. Any adjacent side that face the angle theta that we are considering is going to be called opposite. So it means that side C is what? Is opposite. Then anywhere angle 90 is facing, this is angle 90. Anywhere angle 90 is facing is going to be called hypotenuse. And that's what? B. Anywhere that the angle that remains, that is the third side out of the three sides, we are going to call that what? It will remain adjacent. And that's A. Do you guys understand this?
Yes, sir.
Yes, sir.
Any angle that you are considering, anywhere that angle is facing is going to be your opposite as at that time. Anywhere angle 90 is facing is going to be your hypotenuse. And the last side, you consider it to remain adjacent. Do you understand that now? Fine.
Yes, sir.
Remember when you are in GSS class, the way they define hypotenuse for you is that it's the longest side in a triangle. Absolutely, they are correct that hypotenuse is the longest side. But right now that you are now in SS class, you'll be doing some proving. You'll be doing some diagram that the diagram will not be drawn to scale. What by not drawn to scale is that it's not going to be drawn appropriately. Whereby you can see other side that is not hypotenuse to be longer than the hypotenuse. So for you not to run into that trouble of picking the wrong hypotenuse, that's why you should know that anywhere angle 90 is facing is called hypotenuse. And forget about what you have been taught in the junior class. Because what happened about learning is that you are told that this is this based on your level of exposure, based on what your head can comprehend at that time. By the time you get to university, you start to see another way of determining or tagging hypotenuse. You might not be hearing it to be that, oh, anywhere angle 90 is facing is the hypotenuse. It might be another property that will make you know that, okay, once you see this property, oh, then this thing is hypotenuse. I'm not saying it exists, but it might be. That's one thing about what? Learning. So you get to know more and more and more as you are what? Growing. You know, when you're in primary class, like maybe let me say primary 3 or primary 2, when somebody tell you that 3 minus 2, what will be your response?
Cannot go.
It cannot go, not you. So it's not possible. But by the time you get to GSS, this is not what I want to say. I want to say 2 minus 3 rather. So you tell the person that it's impossible, right? But when you get to GSS class, you get to know that you can actually borrow. Are you getting this now? Or you can even have your answer to be -1. So learning is just from simple to complex, especially in schools. So let's back to this now. We now want to define the side of a triangle in terms of trigonometry ratio. Are you getting it now? So we can now state our trigonometry ratio as follows. The first one, we have what? Sine. That's the first trigonometry ratio that we have, sine. This is the right way to write it, sine. But we always write it as what? S-I-N. Are you getting it now? We now pronounce it as what? Sine of an angle, that is sine theta. What's the definition? Opposites over hypotenuse. Are you getting this now?
Yes, sir.
Sine is opposite over hypotenuse. So what's the opposite in this our triangle?
C.
C.
Our hypotenuse is what?
B.
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 So that tells you that with this triangle, sine theta is equal to C over B. Then the second one is called cosine. It's called what? Cosine. So if you say cosine theta, that is what we always write as cos theta. Instead of writing it as cosine, you know, sine theta is written as what? Sine theta. What cosine theta? We write it as what? Cos theta. And what will be the definition? Cos theta will be what? Adjacent over hypotenuse. Adjacent divided by hypotenuse. So, and what is our adjacent from the triangle?
A.
Our adjacent is A, and our hypotenuse is what?
B.
B.
So we have that cosine theta that we always call cos theta to be adjacent over hypotenuse, and that is A over B according to our diagram. Can you take this down so that I can clean now? Can you take it down fast so that I can clean the board?
No, sir.
All right. So the third one is what they call the tangent. Tangent of theta. Tangent theta. This tangent theta is what we always pronounce as tan theta.
Tan theta.
And it is given as opposites over adjacent.
Adjacent.
So what's our opposites according to our triangle?
C.
C.
Our opposite is C,
C.
and our adjacent is what?
A.
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 So we'll go to the fourth one now. So the fourth one, I told you earlier that we only have 3 trigonometry ratios. And those 3 are sine, cosine, and tangent. So all these 3, they now have inverse. The inverse of sine. Inverse of sine is what we called cosecant. Cosecant. That's the inverse of sine. Cosecant. That's what we always called cosec. So cosecant theta is the same thing as pronounced as cosec theta. So cosec theta is 1 over sine theta. So if you have 1 over sine theta, that will be 1 all over opposites. Okay, I think it's too long. 1 all over opposite over hypotenuse. And this will just give us what? Hypotenuse all over opposite. And our hypotenuse is B, and our opposite is C. So the fifth one is going to be the reciprocal, that is the inverse of cos. And when you talk about the inverse of cos, You are talking about what? The second. So that is number 5. We have secant theta. So secant theta is what we always write as sec theta, and that's equal 1 all over cos theta, and that is equal to 1 over adjacent all over hypotenuse. That gives us hypotenuse over adjacent, and that will give us b over a. So the next one that we have, which is the 6th one, that's what we call cotangent. Cotangent. Cotangent theta is what we always write as cot theta, and that will become 1 all over tan theta, and that will give us 1 divided by opposite over adjacent, and that will give us adjacent over opposite. Do we get this now? Do we understand all of this?
Sir.
All right. Now, I said it earlier that hypotenuse is the longest side. It's always the one with the highest value. Now, I quickly want to test us because there is something that we need to learn that we are not learning. And in most cases, our teachers, they fail to tell us in class, because the job of a teacher is to tell you where to look. They won't tell you what to see. But as a student, at times, you say what?
You not write A over C in the cot theta.
Okay, that's true. Yeah, thank you. So, at times, as a student, you need somebody to activate your passive components. So, and that's what I want to do this morning with this example. You need to start knowing how to observe and extract information. Observe and extract information. A lot of things are there that teacher will never tell you, but questions can take you to those places. The topic you know will now look as if you don't know that topic. And what's that? I want you to tell me the one that is wrong in the following. I want you to tell me which one is wrong and why it is wrong. Sin theta is 3 over 5. Cos theta is 4 over 3. Tan theta is 1 over 2. Cosec theta, okay, let me just leave it within these 3 first. Yeah, let's leave it within the 3 first. Let me pick another one. Sin theta is 13 over 10, and cos theta is 8 over 10, and then tan theta is 10 over 13. So which one is wrong out of all these options that are all these values that I listed out? Which one is wrong? Which one is wrong? It might have more than one that is wrong, and it might be only one that is wrong, and anyone might not wrong there.
Sir, the one that sin theta is 3 over 5, cos theta is 4 over 3, and tan theta is 1 over 2 is wrong.
Hello, let me tell you something. All these are standing on their own. No? They are not like objective question. No?
Okay.
Sin theta exists on its own, cos theta exists on its own, tan theta exists on its own, sin theta exists on its own, cos theta exists on its own, tan theta exists on its own. So look at these 6 things now. Which one is not correct? Which one is not possible? For you to get that question right. Which one is not possible?
Sir,
I'm with you.
Sin theta equals to 13/10 is not correct.
Okay, one. Is that the only one?
Yes, sir.
Okay, that's the only one that is not correct there.
Yes, sir.
Okay, why is it not correct?
That equals to
So it's because the
Somebody saying something downstairs. What's that person saying?
that equals to 4/3.
Okay, theta equals to 4/3 is not correct also.
Not correct.
Yes.
Because 10 equals to 4/3.
Okay, which other one is
yeah,
not?
okay, it's not, yeah, it's not correct. It's
All
not
right,
correct.
which one is not correct again?
So only those two.
Okay, why?
Because the hypotenuse is less than the opposite and the adjacent.
Exactly. You're able to see what I was expecting you to see. So you should know that it's not possible for the denominator of either cos or sine to be less than the numerator. So long you are dealing with sine and cos, the denominator will always be greater than the numerator. Very important. And I'm glad that you guys are able to note that. All right, thank you for that. So I believe we understand this now, right?
Yes,
Yes,
sir.
sir.
Okay, so let's take some example here. Let's take some example here. Can I clean this?
Yes, sir.
All right. So the very first example that we want to look at, example 1. We are told that given that sine theta is equal to 8/17, calculate the values of cos theta, calculate the value of cos theta, tan theta, and cos theta plus sine theta divided by cos theta minus sine theta. I believe we got this right. All right. So here is the question that we have here now. What's the first thing to do? The first thing to do here is to write solution. And I believe everybody agree with me with that. All right. Solution. Now, in order to solve this question appropriately, the first thing we want to do is to recall that sine theta is equal to opposite over hypotenuse. And I'm taking this question the way you should take it in your Waec. Are you following now? I'm taking it the way you should take
Yes,
it in
sir.
your Waec.
Yes, sir.
Opposite over hypotenuse, that is the definition of sine theta. So if we are now given that it is 8/17, that means that our opposite is 8. Our hypotenuse is 17. We have to look for cos theta. Cos theta is what? Adjacent over hypotenuse. Are we given adjacent here?
No.
That
Sir.
means we don't have adjacent. Before we can even say we want to go for cos or tan, we must find the value of adjacent first. Am I right?
Yes,
Sir.
sir.
Now, for you to get the value of adjacent, the first thing you want to do is to sketch the what? The diagram. So we say consider the right angle triangle ABC. We say consider right angle triangle ABC. So how do we consider that? We have this. Sorry. All right. So this is A, B, C. Now, note very well. I want you to note something. When you say consider right angle triangle ABC, make sure that the angle 90 is on B. Is that taken now? Anyone that is at the
Yes,
center,
sir.
make sure anyone that is saying right angle triangle, make sure that anyone that is at the center is the one taking the right angle. Is that taken now? So
Yes, sir.
you can just say consider angle C to be the what? The theta. Or you can consider A to be the theta. So let me consider A to be the theta. Any one of it. If you consider C or A, you still arrive at the same answer. So I consider what? A to be the theta. So that means my opposite is going to be here, and that is 8. My hypotenuse is here, that's 17. And here is my adjacent. Let me say it is equal to x. We don't know it. Now, since we have a right angle triangle, we now think of getting the missing side of the right angle triangle, then we think of Pythagoras theorem. So you state it there that using Pythagoras theorem, we have what? Hypotenuse square, that is the AC square, equal AB square plus BC square. So our AC is 17, so we have 17 square. Our AB is x, so we have x square, plus our BC, and that is 8. We have 8 square. So if this is what we have, we can therefore say, this will give us 17 square to give us 289, Abi.
Yes, sir.
289 equal x square plus 64. So make x squared the subject of the formula. X squared equal 289 minus 64, and x squared will give us
Yes.
169, right?
Yes,
Sir,
sir.
No, sir. 225.
No,
225.
225.
225.
Okay, 225.
225.
All right.
Yes.
Yes, sir.
So this will give us 225. So x equal the square root of
Square root of
225.
225.
And this will give us
15.
15.
15.
So we have gotten our adjacent to be what? 15. So if that should be the case now, we can now find the what they ask us to look for. So the first thing we want to do is to recall that opposite is equal to what? 8, hypotenuse 17, adjacent 15.
15.
We now have that sine of theta equal 8 over 17. Then cos of theta will become what? Adjacent over hypotenuse. And that will be 15 over 17.
15.
And the next one they ask us to look for, tan theta is going to be what? To our opposite over adjacent. So that the tangent of theta is going to be opposite 8 over 15.
15.
You understand this now? So we have
Yes,
answered
sir.
Roman figure 1. We have answered Roman figure 2. So we have to answer Roman figure 3 now. And what do we have in Roman figure 3? We are told to find cos theta plus
Sin
sin theta divided by cos theta minus sin theta. Cos theta minus sin theta. And that will just become, our cos theta is 15 over
15 over
17
17
plus 8
Plus
over
8 over
17.
17.
Everything divided by,
over 15
sorry,
over
over 17
15 over
17
17
plus
minus 8
minus
over
minus 8
8
over 17.
over 70.
minus 8 over 17. And that will just give us 15 plus 8.
32.
32.
15 plus 8.
32.
Opal is where?
23.
23 and
Uh-huh.
23.
15 plus 8 will give us 23
20
over 17
17
divided by 15 minus 8.
7
7
We have
7.
7 over
over
17. Abi?
17
17.
So we say far, far, near, near. So that will be 23 times 17 all over 17 times 7.
17 times 7.
So Aboki Pamala, 17 cancel 17. So your result is going to be what? 23 all
23
23
over
over
7.
7.
And that's our answer. So do you guys understand this?
Yes,
Yes, sir.
sir.
Yes, sir.
Okay. So you can take it down now. Okay, I think it started from me, right? Okay. Question 2 now.
That is not useful. What have you achieved?
All right, take down. If tan theta, if tan theta, if tan theta equal 5 over 12 and you have 0 less than theta less than 90 degree, find Roman figure 1 sine square theta, Roman figure 2 cos theta minus sine theta, figure 3 cosec theta. Now, before I move on, I have to go back to how to read this kind of a question. You're a mathematics student. You should know how to read mathematical language. So because I want to explain how to read it, that's why I pronounce it the way you are going to pronounce it. You pronounce it as 0 less than theta less than 90 degree. That's what you are going to pronounce it, isn't it? Am I right? Or is there anybody that can
Yes,
pronounce
sir.
it the right way here? Is there anyone that can read this thing the way it's supposed to be? Nobody. Are we saying nobody? You said?
That
Okay, nobody. Problem. I'll read it. Now, if you want to read this statement, you read it as if tan theta equal 5 over 12 and theta lies between 0 and 90 degree. Theta lies between 0 and 90 degree. And
Okay.
what does it mean for theta to lie between 0 and 90 degree?
Is in the
What it
middle.
means is that it is what? It is an acute angle. If tan theta equal 5 over 12 and theta is an acute angle, that's another way of reading this. You don't want to read it as what? If tan theta is 5 over 12 and theta lies between 0 and 90 degree, you can read it as what? If tan theta equal 5/12 and theta is an acute angle.
Angle.
Do you understand that now?
Yes, sir.
Because an
Sir.
acute angle is an angle that is less than 90 degrees.
90 degree.
So if that should be the case now, can we move on?
Yes, sir.
Yes, sir.
So the first thing to watch is to recall that tangent of theta is opposite all over adjacent, and that will equal 5/12. Am I right? So if we have that to be 5/12, that shows that our opposite is 5 and our adjacent is 12. Am I making sense? And
Sir.
we have to look for sine of theta, right? So we cannot get sine of theta because sine of theta is opposite over hypotenuse. So hypotenuse is not part of what we can get here. So that means we need to find our hypotenuse first. Are we together now? So we say consider right angle triangle ABC. And what's this? We have this. So this should be so this is going to be A, B, and C. So this is angle 90. Let this one be our theta this time around. So our opposite is going to be where? 5. Our adjacent is what? 12. Let our hypotenuse be x. So using Pythagoras theorem, we have that AC square equal what? A square plus BC square. So our AC is what? X square. And that equal AB, which is 5 square, plus BC, which is 12 square. And this will in turn give us that x square equal to 25 plus 144, x square equal 169. So x equals square root of 169, and that equals 13.
13.
So we've gotten our hypotenuse to be 13. Therefore, opposite is given to be 5. Adjacent is 12. Hypotenuse is 13. So if this should be the case, we can now find what? Sine square theta. So sine square theta is going to be opposite over hypotenuse square. And opposite over hypotenuse square is written as what? 5/13 all square. So sine square theta is equal to 25 all over 169. So do you get this now?
Yes, sir.
So if that should be the case, we'll go to the next one. Roman figure 2, cos theta minus sine theta. So we need to find cos theta first. Our cos theta is what? Adjacent over hypotenuse. Am I right?
Yes, sir.
So what's our adjacent?
12.
And our hypotenuse?
13.
13.
All right. So here we have now. You can therefore say cos theta minus sine theta is equal to 12 over 13 minus
minus
5
13.
over 13. So cos theta minus sine theta is therefore equal
7/13.
7/13.
7 over 13. That's just it. Is that the whole of the question?
Sir, cosec theta.
Okay, the last one, we are asked to look for cosec theta. All right. So cosec theta, cosec theta is going to give us 1 all over sine theta. That is hypotenuse over opposite. And that was our hypotenuse, 13, and our opposite
13.
is
13.
5.
5.
So have you seen the way we are able to answer the question?
Yes, sir.
Yes, sir.
So if that should be the case now, you can take this down. You can take this down. So I want to look at the relationship between the ratios now. Since we have understand the trigonometry ratio now, and now to use this to determine unknown trig ratio. So we have a relationship, that's subheading, between the ratios. All right. Now, those questions that we solved earlier, some of you that's already understand trigonometry ratio before, you'll be like, there's no need for us to draw the triangle. Or some viewers, they'll be like, you shouldn't draw a triangle, you should have just go directly. No, you don't learn like that. If we do like that, then we are not going to carry those who are not aware. And that's why by the time you get to university, a lot of things that you are doing in secondary school, that is the way you approach question in secondary school, it's not the same way you approach question in high institution. In high institution, nobody expects you to be drawing those triangles, start using Pythagoras theorem to determine the unknown. No, nobody asks you, because they know that you already understand the relationship between one ratio and the other. And even as far as Jamb is concerned, Jamb does not expect you to start using what's it called, Pythagoras theorem, because they know that you should understand Pythagoras triple. You see 3, 4, you should know that what is missing that is going to be the third number is going to be 5. You see 6, 8, you should know that the number missing there will be 10. You see 6, 10, the number missing there is 8. Anywhere you see 8, 10, the number missing there is 6. And anywhere you see what? 8, sorry, anywhere you see 5, you see 13. You should know that the number missing there is 12. So then you think that you should know all of those things already. And that's why you are told that no calculator, because they believe that if you have learned for good 6 years, you're supposed to understand some certain things in mathematics. I get this now. And the only thing you should be coming here is maybe trying to multiply very fast instead of using your head. For every other thing, they believe you should know. You should be able to come up with the value of an angle without calculator. All of those things to cut the story short. So that's why I'm going to be taking you through those step by step so that nobody will assume anymore. You just know that yes, you understand what is happening. So we're looking at relationship between the ratios now. Now, how do we establish relationship between the ratios? I'm going to start by drawing a right angle triangle. I want you to see now, if I have a right angle triangle like this, all right, if I have this, and this is A, and this is B, and here is what? C. So this is small letter A, this is small letter C, and here is small letter B. So let's see, consider C as our theta. We now want to establish relationship now, and I will start by the first relationship that I'm going to be looking into is that of tangents. That is, how tan theta equal to sin theta all over cos theta. So how do we arrive this? How do we know that tan theta is the same thing as sin theta over cos theta? Let's come to our rough page here. Tan theta, if you recall, you know that it is opposite over what? Hypotenuse. That is C over B. And cos theta, you know that it is adjacent over hypotenuse. That is A over C. And then tangent theta, you know that it is opposite. That is C all over A. Anybody that does not agree with this? Are you guys still there with me?
Sir.
Right?
Yes, sir.
So if somebody saying,
Yes, sir.
if somebody now asks you that, or somebody asks you to prove that sin theta over cos theta is equal to tan theta. So what they are simply saying is that you should show us that C over B divided by A over C is going to be C over A. We just say what? Far, far, near, near. So far, far, near, near, we are going to be having what? C multiplied by C. Abi, am I right? Yeah. Oh, there's mistake here. There's mistake here because I'm surprised. It's supposed to be. Yeah, there's a mistake here. This supposed. Nobody observe it. It's supposed to be B. So you'll be having what? C multiplied by B divided by what? B multiplied by A. So that this and this can cancel. You therefore have C over A. You can see that it's true that sin theta over cos theta is definitely what? Tan theta. Do you get that now?
Yes, sir.
In the same vein, that is the same way we have that sin theta over cos theta is equal to tan theta. We also have that cos theta is equal to cos theta over sin theta. If you prove it the same way, you will have the same result. Is that taken out? Now, the third one. To prove this third one, because I would like you to be able to prove it yourself, maybe after the class or anywhere you find yourself. I'll start by applying what's it called? Let me call this star. I'll start by applying Pythagoras theorem to this triangle. And if I do that, I will have let me rewrite it like this. I will have a squared plus b squared to equal c squared. That is Either opposite or adjacent square plus opposite or adjacent square equal what? Hypotenuse square. That's Pythagoras theorem. That's what we are applying to this. So, watch you. I'm going to divide through by c square first. So let's divide through by c square and let's see the identity we are going to come up with. You know, this will give us what? A over c all square plus b over c all square. And that will give us 1. A over c. What's our a over c? Our a over c is what? That's cos, Abi. You guys are not following. You said what?
We are following.
Sir, the cos is
We are
A over.
following.
The cos is a over c, Abi.
The hypotenuse is not c square, it's b square.
Oh, sorry. That's a big mistake here. Okay. You guys should be talking though, since I'm hungry now. So this will be what is it called? A square plus c square
C square
equal b square.
equals to B square.
So we divide through by b
That's
square.
Right.
So this will become
as A over
a over
B
b all square
over B all square
plus c
plus
over b all
B
square
over B all square
equal 1.
equals to 1.
So we'll continue
1.
from here. A over b is the same thing as what? Saying cos theta b. So that will be cos square theta plus c over b is what? Sine square theta equal 1. So we have here that cos square theta plus sine square theta is 1, isn't it? So we can establish another relationship here that cos square theta is equal to 1 minus sine square theta. Or we say sine square theta is 1 minus cos square theta. Have you seen that now?
Yes, sir.
Yes, sir.
So this is the third identity, number 3. All right. So let's move on to the fourth identity now. Remember, when we want to get the third identity, what we did was that we use b squared to divide through. So instead of using b squared to divide through, let's use what? A squared to divide through now. So we are now going to be having a square over a square plus c square over a square equal what? B square over a square. So this will give us 1 plus c over a all square equal b over a all square. So our c over a is what? Tangent, Abi?
Yes.
So we have that tan square theta equal our b over a is sec square theta. That means that 1 plus tan square theta is equal to sec square theta. And we can also establish some other relationship here by saying that sec square theta minus tan square theta equal 1. Or say sec square theta minus 1 equal tan square theta. And this will be so this will be the fourth identity. Am I right?
Yes, sir.
Okay.
Yes, sir.
So we'll go for the fifth identity now. For us to get the fifth identity, we are going to divide through by c square instead of dividing through by a square, right?
Yes, sir.
Okay. So that will become a square
over
plus
c square.
Okay, a square over c square plus c square over c square equal b square over c square. So this gives us a over c all square plus 1 equal B over C all square. A over C will give us what now? That's the
Cot.
is that cot? Yeah, that's cot,
Yes.
Abby. So we have that cot square theta plus
Plus
1
1.
is equal to B over C will give us cosec
Sec.
square theta. Am I making sense now? So we have cosec square theta there. So we can get every other identity. Let me adjust this upward a bit. So we can get other identity here by saying what?
Square theta minus
Cosec
cos
square theta minus cot
square
square
theta
theta equal 1. Or we say cosec square theta minus
minus
cot square theta equal equal what?
cosec square theta minus 1 equals cos square theta.
Thank you, thank you. It means you guys are following. So this will be cosec square theta minus 1 equal cot square
Square
theta.
theta
To be the fifth identity.
by the
So those are the relationship between the ratios. And I want to believe we understand, right?
yes, sir.
Yes, sir.
Okay, let's take everything down now. So don't just know or cram this. You should be able to prove it as well. You'll be able to prove it yourself. And that's a good thing to do. All right, so write fast. All right, so let's take some questions now. Example 1 on this. Are we there?
Yes, sir.
All right. Example 1 states that if cos x equal 5 over 12, find the value of sine x and tan x. So if you remember, if it was before we get to know relationship between the ratios, the first thing we want to do is to start checking or defining cos to know the opposite hypotenuse and to know what is missing. You guys agree with me that that's what we are going to do first?
Yes, sir.
All right, but this time around we are exposed to relationship between the ratios, so we don't need to go through that word stress. We just need to just come up with the relationship between sine and cos. And you agree with me that the relationship is that sine square x, where x is the theta, plus cos square x is equal to 1.
Yes, sir.
So sine square x is going to be 1 minus cos
Cos
square
square.
x, Abi? And then
Yes, sir.
sine x is just going to be the square root of 1 minus cos
Cos
square
square.
x. So we can now find sine x now. So we have this 1 minus, what's our cos? Is given in the question as 5 all over
5
12.
over
So we have
squared.
5 over 12 all squared. That will now become sine x equal the square root of 1 minus 25 all over 144. And that implies the square root of 144 minus 25 everything over 144. Abi?
Yes, sir.
So I'm not sure by this time there is somebody who still wants us to be explaining LCM here. So I'm very sure no one. So let's move on. Sine x equal the square root of 144 minus 169, Abi?
No.
Okay,
119.
19.
Yes.
Are you sure?
Yes, sir.
So what do you say this is?
119 over 20 over 144.
119 over 144. Can you just check? Can somebody press calculator and check this? I'm doubting. Oh, I think there's a mix-up in the question. It is 5 over 13. Sorry, there's a mix-up. It's supposed to be 1 over 13, 5 over 13 rather. Yeah. So this one is going to be 13. And this one is going to be 13 square, that is 169. And this one is just going to be 169 minus 25.
That is 144.
Okay, I'm coming. Let me clean the denominator also. This will be 169. So this will now be 144 all over what?
169.
169. So do you know how I get to know there's a mistake now? Because as I've seen 5 and I've seen 12, I know the next one's supposed to be 13. Are you getting this now? So, and 13 cannot be at the numerator. It's supposed to be at the denominator. So, and that's why I guess to see that I think I mixed something up in writing the question. So, once you understand all of these things, when you are making a mistake, you get to be able to spot your mistake before any other person should do that for you. So, square root of 144 is 12, and square root of 169 is 13. So, sine x is equal to 12 over 13. I can see the way we are able to get our sine without drawing any triangle or using Pythagoras theorem. So the second question is what we want to look at now. And that second question states we should look for what? The tangent of x. So we just go back to the relationship again. That means sine x all over cos x. And that's equal. What will be our sine x?
12 over 13.
12 over 13. Our cos x.
5 over 13.
Huh?
5 over 13.
5,
5 over 13.
5 over 13. So we have far, near. So that will be 12 multiplied by 13 divided by 13 multiplied by 5. So 13 and 13 would cancel. I therefore have that tan x is equal to 12 over 5. And that's just it. You can see we got the value of sine and tan without drawing any triangle. So you can take down the question and the solution now. So before we move to the next example and the next heading. So there's no point in we taking another example again. This is just how you use relationship to solve trigonometry problem. So we have talked about how you can use the trig ratio directly to solve and how you can use the relationship to also solve. Do we all understand that?
Yes, sir.
All right, so
Yes, sir.
let me give us assignment on this so that in the next class we can just pick another phase of trigonometry, and that's complementary angle. And you get to see how you can use complementary angles to find unknown angle and so on like that, instead of using your calculator to find the sine inverse or cos inverse and so like. So all of those things are what we're going to be tackling in the next class. So here is our assignment, so we can take it down. So make sure you do well to attempt them successfully. So the first one says that given that, take it down once, given that sine theta is equal to 8 over 17 and theta lies between 0 and 90 degrees, find the values of figure 1 cos theta and figure 2 cos theta minus sine theta, cos theta minus sine theta all over sine square theta. And number 2, we have if tan alpha If tangent of alpha equal 21 over 20, calculate the values of 1 plus sine square alpha, 2 sec alpha, 3 sec alpha minus cosec alpha divided by sec alpha plus cosec alpha. So and I think this is just fine. So let's try this now as our assignment, and I pray God will assist us. Please, is there any of you that doesn't understand the whole of the things we talk about in this class? I'm listening. No, is there anybody? All right. If nobody has any issue with this at this junction, and I would like to call it a day. So thank you so much for sparing your time to be here, and see you in the next class by God's grace.